Hey guys, today we're going to be talking about black holes. So, what's a black hole? A black hole is a place in space where gravity pulls in so much that even light can't get out. The gravity is so strong because the matter has been squeezed into a tiny space. This happens when a star is dying. Because no light can get out, people can't see black holes. So, like, if I go outside into during the night and I try to look for a black hole, I can't see it. They are invisible. Space telescopes with special tools can help find black holes. The special tools, they these special tools can see how stars are very close to the black holes act differently than the other stars. So let's say a regular star is blinking, right? And a star close to a black hole is blinking maybe slower or faster. I would say slower, right? Because the black hole is sucking in and maybe sticking in the light too. How big are black holes? Black holes can be big or small. Scientists think that small black holes are as small as just one atom. So really really tiny. But these black holes are very tiny but have a mass of a large mountain. Mass is the amount of matter or stuff in an object. So even though like um they're tiny, like really small, like an atom is really really tiny, like the tiniest thing in the world, right? But they're really heavy, like a mountain. So imagine a really, really heavy little tiny particle. And then again, imagine like the biggest black hole ever, how many mountains, the weight, how heavy it would be, right? An artist's drawing shows a current view of the Milky Way galaxy. So right here, you're seeing that drawing. Scientists' evidence Scientific evidence shows that in the middle of the Milky Way is a supermassive black hole. So right in the middle of that galaxy is a black hole. They call it the black hole, the Sagittarius A, and it's right in the middle of the Milky Way galaxy. How do science how do they form black holes? Scientists think the smallest black holes are formed when the universe began. Stellar black holes are made when the center of the very big star falls upon itself or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. Scientists think supermassive black holes were made at the same time the galaxy are in. If black holes are black, how do scientists know they are there? A black hole cannot be seen because strong gravity pulls all of the light into the middle of the black hole. So they're pulling the light, right? But scientists can see how strong gravity affects the stars and gas around the black hole. So imagine everything surrounding the black hole. They can see how something's affecting it, right? Scientists can study stars to find out if they are flying around or orbiting a black hole. So they act weird. So like if they're studying the sky and they see all these normal stars and out of nowhere in this spot is like they're all acting weird. That's whenever they're thinking there's a black hole there. When a black hole and a star are close together, high energy light is made. The kind of light cannot be seen without human eyes. Scientists use satellites and telescopes in space to see the high energy light. Could a black hole destroy Earth? That's like a big question, right? Like, what if like we get sucked into the black hole, right? Black holes do not go around in space eating stars, moons, and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. So I guess that's one less worry we have to worry about. Even a even if a black hole, the same mass of the sun, were to take the place of the sun, Earth would still not fall in. The black hole would have the same gravity as the sun. Earth and the other planets would orbit the black hole as they orbit the sun now. So we would just be going around in circles. Like instead of going around in circles of the sun, we would be going in circles of the gravity, the black hole. The sun will never turn into a black hole. The sun is not a big enough star to make a black hole. So here's one crazy fact about a black hole, or the first amazing fact of black holes. Black holes distort the time and space around them. If you happen to fly near a black hole, its extreme gravitational pull will increasingly slow down time and warp space. You'd be tugged ever closer, so you'd be tugging into it, gradually joining an acceleration disk of orbiting space. So you'd be like a swirly thing, like a big long, like kind of your body would turn into like spaghetti, right? Gases, stars, and planets. So you're gonna join that swirling, right? Spiraling inwards towards the event horizon or the point of no return. Once you cross this boundary, gravity would overcome all the chances to escape, and you'll be super stretched or spaghettified as you plunge into the singularly at the black hole center, an inconveniently small point with a nostrous small mass where gravity and density theoretically approach infinity and space-time curves indefinitely. In other words, you'd be gobbled up and inhabited in a place that utterly defies those laws of physics as we understand them. Number two, black holes come in miniature, middling, and mammoth sizes. So the sizes again, small or big. Middling sizes stellar mass black holes are the most common type. They form when a massive star is dying. They form when a massive dying star or supernova explodes and the remaining core collapses from the weight on its own gravity. Eventually, it compresses into a tiny, indefinite, dense, singular form at the center. In truth, then, black holes aren't really holes, but point of highly compacted matter with outsized gravitational footprint. Stellar mass black holes typically weigh about 10 times more than our sun, though scientists have discovered a few that are significantly larger. Number three, supermassive. Oh no, this is a continuation. Supermassive black holes are the biggest in the universe, so the biggest ones. Some with the massive billions of times that our sun. Scientists don't fully understand how they form, but these enormous celestial mind bogglers have appeared shortly after the Big Bang and are believed to exist at the center of every galaxy, even the tiniest ones. Our own Milky Way galaxy spirals around Sagittarius A, which contains a mass of about 4 million suns. So, very heavy. Researchers have also recently discovered stellar black holes that appear to devour material on gases that are slower rate, meaning fewer X rays are emitted, so they are harder to detect. Astronomers also believe there are tiny primordial black holes formed in the second of the Big Bang. These many mysteries have yet to be observed, but the smallest may be more minuscule than an atom, but with the mass of an asteroid, and the universe may be swarming with them. Number three, there are many black holes to count. The Milky Way galaxy alone is thought to harbor some 100 million stellar mass black holes, plus supermassive A, Sagittarius A, at its heart. With 100 billion galaxies out there, each one with 100 million stellar black holes and a core supermassive monster, not to mention other types discovered, it's like trying to count grains of sand. So there's a lot, so many out there. We can't really count them. Four, black holes devour things and regularly spit them out. So they go in and they come out. Rest assured, black holes don't roam the universe like hungry predators, stalking planets and others' prey for dinner. Rather, these heavily beasts feast on material that orbit too close, like this unfortunate star that the universe have watched being swallowed for the last decade, the longest black hole meal ever recorded. The good news is that the Earth is in a collision course with any known black holes currently, maybe in the future. But just because we're unlikely to be slurped down doesn't mean we shouldn't worry. That's because Sagittarius A, and presumably other supermassive occasionally fling out planet-sized spitballs and could someday do us in. How do spitballs escape a black hole's clutches? They're actually made of matter that slips from accretion disk before passing the point of no return and collides into chunks. In the case of Sagittarius A, these hefty pieces spewed into our galaxy at up to 20 million miles per hour. Here's hoping one never zoomed too close to our solar system. 5, 2 more to go, or 3 more to go with this one. Supermassive black holes are also give birth to stars and determine how many galaxies are stars a galaxy gets. In the same way the planet-sized fragments are expelled from a accretion disk, a recent discovery shows that the behemoth black holes occasionally unloosen of material to form a new star. Even more remarkably, some even land in a deep space well beyond their galaxy of origin. And a new study in the journal Nature, released in January, suggests that the supermassive black holes are not only creating new ones, they control how many stars a galaxy gets by directly impacting how quickly the process of star formation turns off. Star formation, perhaps strangely, stops more quickly in galaxies with smaller, in a manner of speaking, black holes at the center. 6. It's possible to stare into abyss. The new Event Horizon Telescope, powered by 9 of the world's highest resolution telescopes, recently took time photos of the event horizon surrounding 2 black holes. One is our own Sagittarius A, and the other is a super black hole at the center of the galaxy Messier 87, 53 million light years away. The image of the latter, now dubbed Poway, astonished astronomers in April 2019. But the photo sessions also raised new interest in ongoing questions about what black holes look like and how mind warp But the photo session also raised new interest in ongoing questions about what black holes look like and the mind warping laws of physics that drive them. 7. The last incredible fact of black holes. Yet another black hole head scratcher. Astronomers in South Africa recently stumbled upon a region of distant space where supermassive black holes and several galaxies are aligned in the same direction. That is, their gas emissions all jet out as though they were synchronized by design. Current theories can't explain how black holes up to 300 million light years apart appear to be acting in concert. So, remember, light travels through space slowly and it gets here really slow. So they're saying, why are we receiving all this light from outer space at the same synchronous way if they're all their timelines are different? In fact, the only way it's possible, say researchers, is if these black holes are spinning in the same direction, something that may have occurred during galaxy formation in the early universe. So there you have it. 7 incredible facts about black holes. I told you what they were. And I really like black holes. Like, it's really interesting to see. Like, I wish one day we could actually see what's inside one. Or like send a camera inside and see like what's in there or how it feels. Maybe send something alive. Like, I wouldn't personally volunteer to jump into a black hole, but I would want to see what happens. Or maybe we could put like a stuffed animal or something and see if it gets torn up. Or, I mean, they say things go in and they get spit out, but yeah. All right. Thanks for watching. Until next time. Bye.